Right now, somewhere beyond the outermost edge of the solar system, a machine the size of a small car is drifting through a silence so complete it has no real name. The temperature of the void pressing in around it hovers at negative 270 degrees Celsius, 1 degree above absolute zero, the theoretical floor of existence, the point where molecular motion ceases entirely, where matter runs out of places to go. Voyager 1 has been out there for over 45 years. It launched in 1977. It has traveled more than 23 billion kilometers from Earth. It crossed the boundary of our solar system over a decade ago. And as of right now, it still transmits, still sends data home, still speaks to us across an emptiness that should have swallowed it whole. A machine built in the 1970s, surviving the most hostile environment humanity has ever reached. The reason it hasn't frozen solid tells you something about the universe that most people never learn. Here is the thing you have wrong about the cold of space. When winter air hits your face in the morning, what you feel isn't simply an absence of warmth. It is billions of molecules colliding with your skin, each one stealing a small fraction of your body heat. The more collisions, the faster you lose warmth. That process is called conduction, and it requires matter. It requires contact. It requires something to actually touch you. In the interstellar void where Voyager travels now, there are perhaps a few atoms per cubic centimeter. Compare that to the room around you, roughly 10 billion molecules in the same space. The difference is so vast it stops meaning anything as a number. With almost nothing to collide with, heat cannot conduct away from a spacecraft. The cold of deep space doesn't attack. It doesn't rush at you. It simply waits for your heat to bleed outward through infrared radiation, slowly, in all directions, into nothing. And radiation is slow. Patient. If you generate heat faster than you lose it, you survive. Voyager 1 has no solar panels. That was a deliberate choice. By the time the spacecraft reached Jupiter, sunlight was already 25 times weaker than at Earth. By Saturn, weaker still. In interstellar space, solar panels would have been dead weight, cold, useless, a monument to the wrong assumption. So engineers chose something older and stranger, plutonium-238, 3 radioisotope thermoelectric generators sealed inside the frame, converting radioactive decay directly into electricity. No fuel, no combustion, no sunlight required. The plutonium simply disintegrates, releasing heat as it does, and that heat passes through thermoelectric materials. Substances that generate a current when one side is hotter than the other. No moving parts, no maintenance, no switches to throw, just physics, running silently and continuously in the dark. At launch, those generators produced around 470 watts of power, enough to run a few light bulbs, modest, sufficient. And critically, they produced heat, warmth that spread through cables, through circuit boards, through the spacecraft's frame, holding everything inside operational temperature ranges. Wrapped around all of it, multi-layer insulation, ultra-thin sheets of mylar and Captain stacked together with near vacuum gaps between each layer. Each layer reflects infrared radiation back inward. Each gap blocks conduction. Together, they create a thermal envelope so effective that Voyager's interior remains warm enough to function, while the surrounding universe sits 1 degree above the coldest temperature that physics permits to exist. In August 2012, Voyager 1 crossed the heliopause. the boundary where the sun's magnetic influence ends and true interstellar space begins. The solar wind stopped. The electromagnetic environment shifted. The spacecraft entered a region no human-made object had ever reached before. And it kept functioning. The generators kept producing heat. The insulation kept holding it. The transmitter kept firing signals back toward a planet that was now, from Voyager's perspective, just another faint point of light among billions. But plutonium-238 has a half-life of 88 years. Every year the output falls by roughly 4 watts. Since 1977, Voyager has shed nearly 40% of its original power. NASA has been managing that decline for decades, shutting down instruments one by one, deactivating heaters for non-critical systems, allowing peripheral components to cool and partially freeze so that the core can keep running. It is a slow, deliberate, engineered surrender. Current estimates place the final instrument shutdowns somewhere between 2025 and 2030. Some may already be dark by the time you watch this. When the last transmitter finally loses power, there will be no explosion. No dramatic final broadcast, just a signal crossing 23 billion kilometers of empty space, taking over 21 hours to arrive, and then silence. The kind of silence that doesn't end. But Voyager doesn't stop. In space, there is no friction, no air resistance, no force to pull a moving object down. Newton's first law at cosmic scale: an object in motion remains in motion forever until something stops it. Voyager 1 is moving at approximately 17 kilometers per second. When its last circuit goes dark and the warmth finally bleeds out through the insulation into the void, it will still be traveling at 17 kilometers per second. In roughly 40,000 years, it will pass within 1.6 light-years of a red dwarf star called Gliese 445. Not a collision. Just a pass in the dark. No instrument will record it. No signal will confirm it. Just a frozen machine drifting past a distant sun, carrying a golden record pressed with the sounds of oceans, the voices of children, the music of a species that briefly existed on a small planet and chose, for reasons that are difficult to explain rationally, to reach outward anyway. What we are losing is not a spacecraft. It is the last physical evidence that something we built and launched kept going long after we expected, long after we planned, long after most of the people who built it were gone. When it finally goes silent, the craft itself continues, frozen, unreachable, dark, traveling through the galaxy for millions of years, carrying everything we were into a universe that will not notice. But we will.